Hi guys, let's talk about separable differential equations today through some examples. Okay, so first describing the general form of separable differential equations. So this is what they generally kind of look like. Okay, you'll generally have like a derivative, and that would be equal, like the first derivative over here. Okay, so let's have a look through some examples how this can come into play. Okay, so let's say we've been given to find, y derivative t equals y squared times e to the negative t, where y of 0 equals half. Okay, let's first find the general solution to this equation. Okay, so what I kind of like to do when I see this, right, I kind of like to write down dy over dt. Okay, dy over dt. Since we're this is another form. This is both are the same thing, but this is in a different form. Y you will see in a bit. And this side y squared, since this is e to the negative t, I'm gonna write down e to the t on the bottom. Okay. So next step, what we want to do is get each side to their respective letters. So like this is dy, right? So we want to get all the y's to one side. Okay, so if I divide y squared both sides, I can get the y squared on the left side. And if I kind of multiply dt both sides, I'm gonna get dt over e to the t. You could also cross cross multiplying. Do not cross multiply in this situation. But what you want is, like, you want the dy or dt on the top when you're trying to solve this. Okay. Next step, find the integral of both sides. Okay. Integral of the left side over here, right? It's gonna be negative. Since this is negative y to the negative 2, right? What its integral would be y to the negative first, negative multiplied to the front. Okay, equals, this is dt over e to the t. Okay, we could think of it as e to the negative t, guys. E to the negative t. We could think of it like that. And again, its integral would be e to the negative t. The plus c might be thinking where it goes. It would be one down the right side, the plus c. Okay, so this is going to be 1 over y, negative 1 over y equals negative e to the t plus c. Okay, y is going to be equal to 1 over, so we do the reciprocal. Okay, 1 over, and now the negative signs, right, we could cancel those out, the negative signs. And since this is just plus c, we don't have to worry about this plus sign. Okay, so negative signs are going to cancel out. It's going to be 1 over e to the negative t plus c. Okay, guys, now this is our general solution. We got to find our particular solution. So how do we do that? We first look at what our y of 0. Okay, so y of 0 is given as half. Okay, so what we could do is plug in e to the 0, right? E to the 0 plus c, because since we've given that y of 0, right, we could plug that into our t value. Our half, we could equal this function to half. Okay, we know anything to the raised to the power of 0 is just going to be 1. So 1 over c equals a half, and then c is going to be equal to 1 over 1 plus c, right? 1 over 1 plus c. Let's not forget the 1 plus c, right? The 1 still is going to matter. Okay, so it's going to be 1 plus c equals 2, and then c is going to be equal to 1. You guys? So that's in a particular solution, right? Since we found our c, a particular solution is going to be y equals 1 over e to the negative t plus what we found our c, right? So that's our c value. Okay, guys, that is our answer. This is our particular solution. I'm going to write it as PS, and this is our general solution. I'm going to write it as GS. Okay, now let's have a look at another example. Let's say we've been given y prime of x, okay, equals x squared over y squared. where y of 1 equals to 2. Step number 1, I'm going to make sure I get that as dy over dx, okay? Equals x squared over y squared. Next step, I want to get the y's on both sides, okay? So I kind of cross multiply, okay? Because cross multiplying I would still get the, that would get my dx to the top, okay? I do not want my dx on the bottom. That's why I did not cross multiply last step, guys. So I'm going to cross multiply because that y squared times dy equals x squared times dx. Do you see how the dy and dx are both on the top? That's what we want. Okay, we do not want them on the bottom. Okay, so now next step, we could do our integral. Okay, doing the integral of this, we're going to get y cubed over 3 equals x cubed over 3 plus c. Remember, the plus c is going to go where? On the right side. It's going to go on the right side. Okay, guys? Now, what we're going to do is, we're going to take since this is y to the cube, right? Before we even do that, let's multiply 3 both sides so that we can get the 3 out from this y. Okay? And it's going to be x cubed plus c. Okay? You might be thinking, we multiplied 3 to the c, right? Let's make a note here so that we multiplied 3 times c. Okay? And then y cubed is just going to be the cube root of this. It's going to be cube root of x cubed plus c. Okay? And now this is our general solution, basically, guys. This is our general solution. Let's find the particular solution now. Okay, for that, we know that y of 1 equals to 2. That's what we've been given. Okay, next step would be to plug those values in. So 2 equals to the cube root of, it's not going to be 2 cubed, guys. It's going to be 1 cubed. Because that is our x value, right? So the 1 over here. So 1 cubed plus c. And now if we cube both sides, right? So this is going to be 8 equals 1 plus c. Okay, and c is going to be equal to 7. Okay, so our particular solution for this problem is going to be y equals cube root of x cubed plus 7. Okay, guys, that's it. That is our particular solution. We have a different type of problem, guys. This one is kind of different from the first two that we have done. Okay, so say we've been given dy this time, just dy over dt. Okay, dy over dt equals to y times 4t cubed plus 1, where y of 0 equals to 4. Okay, so again, we want to get the y's on one side and the dt. So that's what I'm going to do over here. Okay, so I got them on both sides. Next step, do the integral of both sides. Doing the integral of the left side, right? We know that if you see like dy over y, du over u, right? That's going to be the natural log. Okay, so in this case, it's just going to be the natural log of y, absolute value of y, equals 4t to the 4th over 4, the 4 is plus t. Okay, guys? So that is t 4th and plus c, right? So ln of y equals t to the 4th plus t plus c. Now, we got to get the y to one side, right? So what we do is we kind of remember a small tweak over here. Remember, it's not just ln y, it's ln e, right? It's the base y, right? So what I'm gonna do is use a small tweak. We're gonna do e to this exponent equals to y. Okay, so e to the t to the 4th plus t plus c is gonna be equal to y. So that's how we kind of unwrap it. Okay, now remember e plus c, right? So that we could also write it as e to the e to the t to the 4th plus t multiplied by c, right? Remember the laws of exponents when you're multiplying with the same base, right? So kind of we're multiplying a number, right? So we could also add that. this was here we were adding, here we could just bring it down, okay? And we were multiplying it over here. So we could also write this down as CE to the t to the fourth plus t equals to the y. Okay, so this is our general solution, guys. General solution. Now we got to find a particular solution. Now we know that y to the 0, y of 0 equals 4. So y of 0 equals 4. So we're going to plug 0 into wherever we have the t. So CE 0 plus 0 equals to 4. So C, we know 0 plus 0 is 0. E to the 0 is going to be 1. So C equals to 4, guys. Okay? So our particular solution, right? Our particular solution is going to be 4e t to the fourth plus t, guys. Plus, yeah. So that is our answer. Alrighty. Now let's see if we could solve one with a trig function. Okay? Real quick. So let's see, we're given y of t equals cosine square y of 1 equals pi over 4. Okay? So we could write it down as dy over t again, cosine square y. Okay? But note one thing, we don't have anything for the t side, right? So we're just going to bring the dt to the other side. So dy over cosine square y equals dt. Okay, take the integral of both sides. What we're going to get on the left side, right, guys? It's going to be 1 over cosine square. We could also write that down as secant square. Y dy equals integral of dt. Guys, we know the integral of dt, right? That's just going to be t. Okay, we're going to put the plus c over there also, remember? The integral of secant square, remember the box, secant, tan. We're going to cross out secant, and we're going to be left with tan. So it's going to be tangent. Tangent of y is going to be t plus c. Okay, we've been given that y. Oh, by the way, this is our going to be our. We gotta kind of unravel this to get our y, right? So our y is going to be, so that tan inverse, remember to unwrap this one, it's going to be tan inverse of t plus c going to be equal to y. Okay, so this is our general solution, guys. And we've been given that y of 1, remember y of 1 is equal to pi over 4. So to find the particular solution, tan inverse of t, what is our t again? So our t is 1, right? Because we're going to plug in 1 plus c equals to pi over 4. So we're going to unwrap this again to get our c value. Equals 1 plus c, tan inverse pi over 4 minus 1 equals to c. So this is our c value, guys. Now we could put in our c value back into our problem. Again, that's what is, before one more step. What is tan inverse of pi over 4? Okay, we got to solve tan inverse of pi over 4. If you look at the unit circle, what gives us pi over 4 in the first quadrant? That is 1, right? So this is going to be 1 minus 1 equals to c. So c is going to be equal to 0. Actually, we're going to solve for tan inverse of pi over 4. Okay, so c we get as 0, and our particular solution we get y equals tan inverse t plus c, which is going to be 0, right? So we don't even need the plus sign. Tan inverse of t. And yeah, that is our final answer, guys. If you did learn something from this lesson, please do like, share, and subscribe. Please do check out my other videos from the Calc 2 playlist. And if you have any questions, please leave them down in the comment section below. Thank you so much, guys. I hope you have a great rest of your day. Thank you.